We're at episode 8 now, where we're doing some programming for the NES, working on a shooter game, shoot 'em up. The last episode we had done some physics cleanup because it was a little bit of a mess with the way it was allowing the ship to gain essentially too much velocity, and so it was scrolling way too fast. We capped that. We capped that with the stream last week so that it would not be quite so not quite so high, because it was we were comparing. Oh boy, it's gonna be one of those streams. We were comparing the value with a maximum velocity and setting the value, capping the value accordingly, so that we didn't have to deal with going quite as fast. So one thing I wanted to do real quick was show it on real hardware, essentially. So just for fun, because it's always kind of neat to be able to get the game on there and working on some sort of real hardware. So I have the retro USB AVS here connected to, I've got an Elgato capture card. So I'm gonna put the ROM onto an SD card here, and we'll just see how this looks. Now, quick disclaimer: I had changed the char ROM to include this title graphic stuff because I want to actually have some graphics here in the game for the title screen. So the background's going to be messed up, but that's okay. I just wanted to. That will not be a surprise to me, and should not be a surprise to you either. So I'll just take that ROM, drop it into the SD card, eject it, and then put it into the EverDrive, and then put that into the AVS. We'll switch over to the AVS video here, and grab my controller and boot that up. There we go. So you can see it picked up the ROM here, and we're gonna start it up. And just like last time, we had the ship and background loaded. Like I said, this is some of the graphics from the title screen that I had created, but it's in the title screen state that we created last time. And if I hit start, it's going to start scrolling, and the ship's display, and we can destroy them. So that's cool. If you remember, the left motion is way too fast. The right motion is a lot more like what you would expect. Same thing with the up motion and the down motion. So we're going to fix that, and then we're going to start making changes so that it actually loads the title screen properly, and then loads up the gameplay mode accordingly. So just wanted to show that. I thought that was kind of cool, that it's working okay on real hardware. It's kind of neat. I mean, if you think about what something like this EverDrive is doing, it's essentially got to simulate the real cartridge hardware, right? Because what you've got on the SD card is just your ROM, and it doesn't have the mapper chip that the real cartridge would have, like the MMC3 mapper or something like that. So the EverDrive is essentially simulating that functionality in order to make the ROM run properly on the AVS, which is treating this like a real cartridge, like any game you would pop in there, like Super Mario Brothers or whatever. So kind of cool. Anyway, just wanted to do something a little different to start off with. So going back to this, the big problem we were facing last week was the speed, the velocity that we were setting for the ship was way too high. And we had capped it on the positive direction, but on the negative direction, we didn't do it because I hadn't looked at how to do the negative comparison properly. So let's take care of that so that we can get that going the way that we want to, so that the ship doesn't fly out of control when you go in the negative directions. So let's see, where is that stuff? So process player, right? So here are the velocity. Here's all the velocity stuff that we wrote. So we're taking the positive case and we're doing the actually this is the negative case because we're setting the carry and we're doing the bit shift to divide. Alright, so what we'd done in the positive case was we had compared the max velocity to the current velocity, and if it was equal to, we were okay, and if it was less than, we were okay, but otherwise we were going to change the velocity to be this max velocity value, and similarly we were going to want a max negative velocity. So our velocity here is 12. We probably want to make the negative velocity be the same thing. So as we talked about last time, the velocity is just a function, or sorry, negative numbers are just a format called 2's complement, where the representation is you're flipping the bit and adding 1 to retrieve the equivalent number. So in the case of 12, let's see, so it's 4 and 8, right, to get 12. So here's 8, and here's here's 4, right? So that should be 12. And just to make sure I don't make any stupid mistakes, we'll double check. Yep, there's 12, which is C in hex. So if we want to flip that to be negative 12, it's this, plus you add the 1. So it's this number, except I'm doing that in decimal, which is wrong. So that's our negative 12, that's F4, I should say. And then again, we talked about this last time, we can show that this is really negative 12, because if we add the two together, we're going to get 0, right? So the first two digits are 0. This is 0, and you carry the 1, and you get 0 here, because the 1 and 1 is 0, and you're carrying the 1, and then you're just carrying all the way down, and you get 0 for the result. So I did that conversion right. That's the value we want, which is F4. So we want to change our maximum negative velocity to F4. Now, is that how you do a constant in hex? I was going to complain about that. You know, I don't know. I usually, most of my constants have been in decimal, so let's just do a real quick check. Max and velocity. I think that's right, but I hate to go off the idea that that's right and then find out that it's totally broken because of that. So once we get past the subroutines that we implemented here, it's loading F4, and that's the value that we wanted, so we're good there, right? That's loading A with F4, which is the max negative velocity. Okay, great. So let's talk about doing comparison for negative velocity. So comparing against positive numbers, we saw that you could do it pretty simply by just doing a comparison operation, and then based on the carry flag or the equal, effectively the zero flag. So if it was equal or if the carry flag was clear or set, we could determine if it was greater than or less than, right? For negative numbers, it's a little bit more tricky. And what you have to do is you have to use the subtraction operator. And when you do the subtraction, what it's going to do is it's going to set the V flag. And and then based on whether V is cleared or set, you have to perform an operation where you do an exclusive OR on the most significant bit. And by doing that, the value of A is changed such that you can then do a branch minus or branch plus to determine if the number is less than or greater than. So this is a little convoluted. I mean, it makes sense if you read the description of how this all works. But what I wanted to show was just a little example of how that all fits together. And I found this really cool project called Easy6502. And while it's a really nice way of learning 6502, it's also a really easy way to test out this code that we want to write and look at the flags outside the context of the game. It just makes it a lot simpler because it's self-contained. So if we wanted to do something like check to make sure that our value, when we're evaluating it, is going to work the way that we expect, what we can do is we can say, okay, let's check the value -1. And the value -1 is FF in a signed byte. And it's going to get loaded into A, right? And then what we want to do is we want to set the carry and we want to subtract from it the value 0, right? I mean, this is pretty simple in the sense that -1 should be less than 0. So now at this point, based on what they're describing here, when we do that, if we do the branch, if V is set to a location to skip over here, right? That means if V is clear, we need to do an exclusive OR on the A register to against the most significant bit. So again, if you're looking at the hex digit, and you know, as I do these videos, if I'm over explaining these things, you know, don't hesitate to comment on the videos or in the chat that I'm over explaining this, because I'm just trying to make sure that this is clear. So if this is the hex value 80, right, then this means that this is the representation in binary, because these 4 bits are 0, these 4 bits are 8, so this is the most significant bit. And that's what we want to apply the EOR to, right? That's what they're showing here. Okay, and so then when we do that, at this point, we can do 2 things, right? We can say if it's positive, then it's saying, okay, so positive means that A is actually greater than or equal to the number, right? And if it's negative, it's going to branch, it'll do the branch minus. So really what we want to do is we want to check if it's essentially less than or equal to, because if it's less than or equal to, we don't need to do anything, we can just move on, right? Otherwise, we want to set A with whatever our fixed value is. You know, in this particular case, we're not using the variable, the constant velocity that we were talking about, the negative 20. But if we just take 0 as that constant velocity for a second, we could just say, okay, if it's less than, excuse me, if it's less than the number, then we would just want to set it to 0. And then let's just move on here, and then we can put a little loop where it just continues to do this. So you just hit assemble, and then what's really kind of cool is you can step through it, but what we should expect to see is that A will be 0 when we're done, because the value will have been overwritten with this 0 value, despite all of the changes that we made doing the subtract and whatnot, right? So we run it and it's 0. Let's make it something a little bit more obvious that we actually change something. It's 5. What we can even do here is we could say, instead of it going to that end infinite loop, we can say set it to an alternate value, right? Just to kind of prove the point that this is actually doing the test as expected. Right, so if A is less than the value that we subtracted, then we are going to set the A value to 10. Otherwise, it will be 5. If I did that right. Alternate. Oh, yeah. Okay. So it's not less than. It's actually the value is A. Wait a minute. Am I confusing myself now? No, A is less than, right? Because A was -1. So it should be going to here. Did I screw this up? Set the carry, subtract the number we're comparing against, branch V. Yeah, I set V set, not V clear. So reverse what I said about V. Okay. There we go. So it did the branch of minus, which meant it went to the alternate value, which is 10. And then it went to the move on part where it's looping. If we made this the value 5 and ran it, it should be, well, let's do a value that doesn't match. Let's say it's the value 0f, and we ran it. We should get the value 5 in A, and we do. So again, I mean, this, you know, you don't have to use this, obviously. I just found it useful for testing out these kinds of things because they can be confusing, since it's kind of a complex sequence of things that you need to do just to do a simple negative value test. So, sorry about the noise. Someone is setting off fireworks in the middle of February. Not the middle of February, the end of February. Perfect. All right. So, in this case, we're doing, this is the negative. So before we do anything to determine if we want to change the value, what we first need to determine is if it's greater than or less than the maximum negative velocity. We want it to actually be greater than the maximum negative velocity because, right, it's the same, I mean, it's the same thing as the positive. It's you want it to be less negative or less positive. So anyway, so let's do that. So we have, do we have the x velocity in there? We do. We have the x velocity in A. So now what we're going to do is we're going to set the carry. We're going to subtract the value, the max negative velocity, right? And then based on the code that we have here, we're going to say, all right, if V is clear, we don't need to do the EOR step. So we're going to say, how do we want to label this? Skip negative X EOR. I think one thing we're going to need to start doing is using CA65 has support for what are called scopes, where you can isolate parts of your code so that they don't overlap things like names, even though you can then reuse some of the names. It just makes it easier to organize your code. So for example, we don't have to have all these crazy long label names like we're using right now. All right, so if we didn't skip this, we have to exclusive OR the A register with with 8, and then we're at the point where we've skipped, and then we say, okay, if we branch, so let's see. So what we want to do is we want to branch if it's positive, because at that point we don't need to cap. We don't need to force the X velocity to be the maximum negative velocity. So if it's positive, meaning the velocity is actually greater than, it is less negative, then we are going to skip X negative velocity cap. Again, like these names are starting to get maybe a little out of hand here, but all right, so let me see if I got that right. Yeah, so if it's positive, we're gonna skip that, and then if it's negative, or yeah, if it's negative, then we know that the value is either equal to or less than our maximum negative velocity, and we want to cap it. So we want to load A with maximum negative velocity, and then we want to store it in the entity's X velocity. Right, so velocity is more negative than max cap the value. So assuming that I didn't mess that up too terribly, at that point it will do the division like we expect it to, and then continue to adjust the player. So what we should expect to see is now when I move in the X direction in the negative, so to the left of the screen, we'll see the same behavior as we saw on the right, where it won't go quite as fast. It'll actually be a little bit more controlled, which is what we want because it was way too fast. So get this controller connected in. Okay, just make sure this is okay. I think this should be good. Let me restart FCUX here. Okay. Okay, good. So, well, that obviously didn't work. What did I do? What did I do wrong? Did I mess up the branch again? Let's see. So we're loading the velocity. If it's equal, because it's 0, then we're gonna go to X velocity done. If it's positive, we're gonna go to remove the velocity, which is fine. Otherwise, we want to now do the comparison for the max velocity. So let's see. So I'm setting the carry which, right, and then we're subtracting the maximum negative velocity. And then if V is clear, we're going to skip the EOR, right? So, and then that will set the EOR if we have the V set. And then if it's positive, what we said is if BPL branches, it's because A is greater than, oh, I reversed the condition that I was checking for, right? A is less than, yeah, sorry. So that's what it was. It should be branching on the negative. All right. Well, it still seems wrong. So if we go, let's reset for a second here and look at the memory. It's still doing the same thing it was doing before. It's almost as if, it's almost like it's somehow, let's see. Right, so you skip, if we're branching on minus, that means A was greater than, no, sorry, A was less than, which is what we want, because if A is less than the maximum velocity, then we don't need to do the cap because we haven't reached the maximum velocity yet. So that's fine. That looks right. I'm kind of curious what I've messed up here, because that seems like that should be correct. So let's see what I can do here. So also someone named Andre commented on one of the on the recording of the last episode on YouTube. He suggested that rather than setting a bunch of no ops in place, that it might be easier to do a breakpoint based on a memory address being set. So we can try that here. So I don't care what the value is. I'm going to store it at 7F. Am I still using that elsewhere? Oh, that was 7FF. So we'll do 7E. Okay, so then in FCEUX, all we need to do is in the debugger add a breakpoint for a write to 07 FE, and that should be it. It should break on at the point where it processes. Of course, looks like I screwed that up today. It's just going to be that kind of day. Max editor. too far. Where's 7? So 7FE will be here. So add right breakpoint. So I just defined that wrong. Here, let me delete both of them here and then add right breakpoint. Edit. No, I did that right. So down scroll, add flyby, process entities. Oh, so yeah, I want to store that to the address, not to the literal value. That would certainly do it. Come on. Okay, so it hit that breakpoint there. All right. So let's do this. Let's do that. We can do that here. We can say store A. Almost did it again. 7FE. So we're gonna, if we hit the exclusive, well, let's just do it here. Right, so once we start dealing with the negative value at all, yeah, all right, so let's build that. I reload that again. Reset, debugger. Okay. Is it on the breakpoint? There we go. Okay. So we did the store. All right. So the value of A after the subtract. So what was the x velocity? The x velocity was FE, which if we look at the binary for is, what is that, 2? That's what it looks like. Or -2 really. Right? Yeah, so it's -2. So that's fine. So we took -2 and we compared it against F4. So if we do that here, FE minus F4, we get A, which is what's in A right now. And then V was set, so we're going to do the exclusive OR on A. And we're going to get 8A. And now it's negative. So we're going to branch over the code where we do the capping here, where we forcefully store the velocity. Oh, I know what the problem is. So, okay, so the problem is that we do this check and we go, yep, it's still less than our, or greater than, really. It's greater than the negative maximum velocity. Great. And then we start doing our division on it. That's not great. And the reason it's not great is because the velocity is not currently in A. What's currently in A is the result of the operations we had to do to determine if we've exceeded the negative velocity, right? So that's why it's going crazy. So what we need to do is we need to reload the velocity. Now, we don't need to do that unless we are here, because in this case we're actually setting the value in A, and it's going to be correct coming out of that part of the code. So I think that was what messed me up, is that I took the case, I jumped on the case where we would need to set it, but then was thinking about the fact that we'd be rolling out of this with it set properly. So in the case where we cap the velocity, we would be coming out with the right value, but in the other cases it would be getting messed up. So let's see. If we change it to cap on to branch on the opposite condition, then what it would do is it would, well, you know what, I'm not even going to go through the mental gymnastics of trying to figure that out right now. It's just simpler right now to take the simplest approach, which is, in this case, a little bit slower, obviously, because we're reloading A twice here. I hate to do this, though. It looks so stupid. I mean, what would we do? We would say, okay, we'd say branch of plus, which means that it's greater than or equal to, which is okay, which means because we don't need to change anything. And then we have to reload A with the velocity. And if we do that, we only need to do that in the case of positive, of the plus, not minus. So what would that look like? So in the case of the plus, we would jump to some spot where it's like reload negative x velocity, right? And then here we do this, and then this would jump to skip x velocity cap, and then here we're doing and then we're falling through. I'm not sure if that's actually better. I mean, it's more convoluted, right? Because we're saying, okay, if it's the case that we, if it's the case where it's fine, we know we need to reload the velocity. So we're going to do that here and then fall through. And if it's the case where we don't need to reload the velocity, we just need to cap it, then we're going to load that into A, store it into the velocity, and then jump to skip the extra load. I don't know. We'd have to do the calculation of what's actually more efficient. And I'm not sure that that's particularly interesting right now. I mean, you're doing, here's what we can do. We can say, look at the, let's compare the two things. So in one case we're doing this, and if we undo those changes, it looks like it's less instructions. Right, and we go to our 6502 opcodes. And the branches are going to be the same. And then we're going to load the value, that's the same. We're going to store the value, that's the same. And then in the case where we've just stored, we're going to do a jump instead of a load A. So a jump it's going to be 3 bytes and 3 cycles versus the extra load, which is going to be 2 bytes and 4 cycles. So it will be a little bit slower and bigger with the right? Did I It's 2 bytes and 4 cycles versus 3 bytes and 3 cycles. So it's a little bit bigger, but it's 1 cycle slower, 1 cycle less rather. But it's a lot more complicated. I'm gonna say this might be 1 cycle more, but for now it's a lot clearer what we're doing. Even though that extra load is unnecessary. Although the 1 load is only because we're going to the 0 page. If we moved, I don't know. You know, sometimes these things, it's kind of like, how much do you think it's going to affect it in the end? We can leave it this case, and then this is technically better because it's not doing the extra load unless it needs the extra load, right? Because it's saying, all right, if it's the case where we're still within a good range, just reload the velocity and then carry out the math. Otherwise, it's doing the capping of the value, and then it's going right to the part where we do the division because it knows it doesn't need to reload it. So oops. Assuming that I didn't mess that up and write all the wrong code and it doesn't work in either way, but hopefully not. Okay. Yeah, it's still broken. Awesome. So we're going to spend this whole stream doing this, it looks like. Why the hell? Seven FE. So let's add that back. Okay. So we've loaded the value of 5. We've done the subtract. It looks like we're in the case where we need to what are we doing? Oh, okay, yeah, right. We're setting that value into memory so that we hit the breakpoint. So then it's going to do the exclusive OR. It's branching because it's positive. No, it's not. It's negative. So let's take a look at these values. So F5 is this value in hex. Sorry, in binary. Which is 11, right? And as a positive number, so it's minus 11. So let's take a look at what got us here. So we loaded positive 11, negative 11, and then subtracted F4 from it, and gotten 1. And then because V was set, we did an EOR on that to get 8-1, which set the negative flag. So now at this point, it is trying to cap that to F4, which is wrong. Did I reverse the conditions again in my brain? If branch minus occurs, then the n was set to 1, which means that a is less than number. Right, so if a is less than number, a was a was the velocity. So if the velocity was less than our max velocity, then branch minus should occur, which yeah, I just reversed the conditions because because if this is, you can see why this gets so confusing with all of these different conditions that you have to write out checking these flags. So we're checking that we're comparing A versus this value, and we want to know that A is less than or greater than, and in this case, I think what I did was I was thinking about the velocity versus A when choosing the branch. So if A, which is the velocity, is less than the constant, meaning that it's past the cap, no, that's right, because A as the velocity is greater than or equal to, it should then branch to I'm looking in the wrong spot. Right? Yeah. Sorry. So if this branches, it's because the velocity is greater than or equal to the constant, which is what we want. We don't need to cap it. So what's wrong with what we're doing here? Branch positive. A is greater than or equal to, then branch positive will branch. So A was the velocity, and if it's greater than or equal to, then we will go to here. But see, that's the weird thing, is that it actually went to this where it's trying to cap the velocity. If we run through it again, now it's F5, right? Because it's gotten to this point here, and it, let's see, so I want to see something. When it increases, Is it going to change the value to F5? It is, but F5, that should be a negative value based on the way that's set. So what is the deal? Let's set a breakpoint here where we're loading the actual velocity. Okay. So we're going to do that. So, okay. So the velocity is F5. So it's not equal. It's not positive because the N flag is set. So we're going to now set the carry, and subtract so that we can do our sign comparison. That gives us the value 1. V isn't set. So now we're going to do our exclusive OR on A, which is currently the value 1, right? So we do our exclusive OR, it becomes 81, which is negative. We have the negative flag set here. And that means that A, which was the velocity, was less than the number. Right, that's okay. That actually makes sense, I think, because F5, let's see, F5, if we convert that to be a positive number, is and then F, wait a minute, that's minus, did I, hold on a second, hold the phone. Hold the phone. 2, 4, 8, so that's minus 12. Did I mess up? So it's doing what it's supposed to in terms of the math, but what did I, minus 20, I must have done the binary for it wrong. So 20 is that, and then we just flip it, right? So 1, 1, 1, 0, 1, 0, 1, 1, and then we add 1. You know, I did this before too, annoyingly. So EC is the appropriate representation. I did this before when I was trying to figure some stuff out and had obviously a detrimental effect to what I was testing, which is why you got to be real careful about the way you do those conversions. And I'm sure there's probably someone out here screaming at me for doing this manually. And if you know of a tool that will do that for me so I don't keep messing it up, I'd appreciate you sharing that with me. I don't like doing it any more than you probably like watching me do it. And messing it up to boot. So, alright, if we go into the debugger. Alright, so let's get rid of this guy, and then is that enabling it? What is that E doing? Or is that turning on execute? I guess it's just enabling it. So let's run. So it's now stuck, and the reason it's stuck is because what I was seeing is that when it does when it's doing this, what it seems to be doing is it's incrementing the velocity because it's a negative. It should go from 20 to 19, right? Let's go to the debugger. Let's watch this happen here. So we're at the point where the velocity is ED, right, which is going to be a problem. So it's going to cap it at EC, and then it stores that into memory, and then it jumps to do the division. Right? So it's going to step over, it's going to do the bit shifts here. So let's test that for a second. So EC in binary is this. And then, so the positive value of that is that's 20, right? And then we did 2 bit shifts, and we end up with FB, which is 5. That's fine because we're dividing 20 by 4, so we're getting -5. That's okay. That's what we wanted. And then we're going to add that value to the x velocity, to the x position. So it's going to change the x position. That's fine too. It decreased the x position, which is good because it's a negative. And then we're increasing. I wonder if it's just the increment that's the problem. I'm not sure why that would be an issue. And I'm not sure why the next time around or every time around, I should say, the value has gone back to being ED. Right, that part doesn't make a whole lot of sense. Because at that point, we're done pressing the directional pad, so it shouldn't be applying anything to shouldn't be doing anything to make the velocity go back down. Right, let's see, we're increasing it here, and then we're done with the x velocity, so now we're going to the y velocity. Are we doing something where we're incorrectly setting the y velocity? No. So let's see. Why? Right, because you see what's happening, right? It's like every time we run through the loop, the velocity should be, this velocity should be decreasing because of the quote-unquote friction, right, that we're applying. Like if it were a positive value, then it would be doing that, which is what it was doing before, which was fine. So if we go in here into the hex editor, and we look at 18, 10, 11, 12, 13, 14, 15, ED, right? And we make it like 7, other than it not actually coming into this loop anymore. Let's see, we go to, you set a breakpoint here. Every time we look at it, it should be, oh, did I, here, let's change it to 7. And yeah, and you can see as I cycle through it, it is decreasing that value, right? Until it gets down to 0. So the question is, why is it not behaving the same way for the positive? Sorry, for the negative velocity. So it's also odd is why is it not doing that every loop through the player? Load entity X. The breakpoint is here. Load A, 1AX. Yeah. That's not the one I just created. That's the one I'm on. All right. Oh no, that's the type comparison. Okay. So this is the actual breakpoint that I want to check. Sorry. So this 9.5 is gone. So let's see. So I'm loading. Yeah. So the velocity is decreasing every loop through. I guess it was just wherever the breakpoint was. It was not good. So like if I make this 18 and I run through here, it's decreasing until it reaches 0, and then it obviously doesn't go negative. All right, so what am I doing differently that's messing this up besides everything? So if it's positive, we decrement, and that's fine. Am I decrementing by more than 1? Is that what we did? No, it's just doing 1 here. Okay. Let me think about this for a second. Is it because we are actually setting Is it because of the fact that it's not just greater than or less than, it's greater than or equal to? Because if it's equal to, we're going to reset the value. We're going to force the value to be the maximum velocity. And then we're going to increment it here, which would... Yeah, but that should still... That should still do what we expect it to do. So let's see here. We do subtract and then store and jump and load. Where is the cap? So here is the cap code. Let me get rid of B8. So let's get rid of this and let this run now. So it should run fine until we hit the left D-pad, and then it breaks on that. Memory, right? So then from that point forward, the velocity is it's just stuck at ED. Or is it am I looking at the wrong? Or is that the other velocity? No, I mean it's ED. So that's the velocity being loaded in. I'm not sure what this is. That's, oh, that might be the scroll position. Yeah, because it's going by twos. That's, or 4. Oh, I'm pretty sure that's the scroll position. But this is never, this velocity is, oh, okay, yeah, never mind. I know what that is. That's the X position. That's, the X position is changing because the X velocity is negative. So, huh. So if it's EC, like, I mean, is it just something really stupid? Like EC, what? That's 236, which is out of the range of assigned byte. So that is a negative number. That's not the problem. And that value is minus 20, right? So minus 20 is what we were trying to cap it at. And we were comparing the velocity to, oh, wait a minute. It does matter that it's greater than or equal to, because the thing is that if we're setting it to be equal to that, we're going to get stuck. We're going to get stuck in a loop. So we're going to get stuck in a loop where we're continuously resetting the velocity, right? Is that right? Because it's equal to after we set it. But, you know, the increment here should, let's do this. Let's just to see if this makes it change. I'm going to increment the X velocity so that it's not the maximum X velocity in the negative direction anymore. It's 1 before that. So that when we come out of here, it's actually going to be 2. What? Just adding that one instruction made us out of range? Damn it. Branch if not equal, skip entity. Is this going to work? No, that's out of range. 2. Of course. All right. So, let's just do this because I just need to fix the problem we're actually trying to fix instead of range problems. Okay, so that's up to date. So, okay, so just to recap, because I got distracted by this range error. I'm storing the capped maximum negative velocity. I'm incrementing it so that it goes from -20 to -19. It then later gets incremented here to -18, so that even if we get -19, because it's still, something still applies a negative x direction to it, which it shouldn't for the x. Nothing should be changing the x velocity, but let's say it does. We shouldn't get stuck like it seems like we're doing. Right? We shouldn't get stuck. Hopefully this means we don't. All right, let's take a look. Yeah. Okay. But still, why is it getting stuck in that? See, that's the thing that's very strange, is that it seems like something is still trying to modify the x velocity after we come out of the, after we stop pressing the key, right? So like on the positive direction, once I let go, it stops. With the negative, once I let go, it continues to have this problem. So is this because... All right, so let's go back to how we're doing this. So we're saying, okay, if it's equal, then we're going to say x velocity is done because the velocity is 0. If it's positive, we're going to... Oh, did I? Okay, so let's just walk through this. If it's positive, it's going to go to remove the x velocity. Otherwise, it's got to do... It's got to... Let's do negative comparison. Comparison bias subtract, right? So it's going to subtract with a carry. I'm pretty sure that you're supposed to do clear the set carry. Okay, yes. So it's going to do that, and then it's going to say, okay, if this is... Oh. Well, yeah, so it should actually skip the EOR when it's supposed to skip the EOR and not just go right to it. So that was pretty stupid. There we go. That's much better. All right, so in the end, I think I can get rid of that extra increment, because the problem was that it wasn't skipping the exclusive OR that it was supposed to do if the V flag was set. So we can get rid of that. And thank you for Andre suggesting that. That is a lot easier than setting a bunch of no ops. I like that idea. And then we can get rid of this because that wasn't necessary. That was just trying to see if that made any difference with the way that it was getting stuck. So once we transition out of, yep, much better, right? That's what I was looking for. That took way too long to troubleshoot. All right, so now we got to do this for the Y. God help us. Same deal though, right? If the where is that code? Skip X and velocity. Okay, process player remove XV, skip forced X velocity. Process player X velocity done. So now we're checking the Y velocity. If there's no velocity, do that. If there's check if it's positive velocity. If it is, then we go to remove. And now here we're going to do the same thing. We're going to set the carry. We're going to subtract the max negative velocity, right? And then if is it V clear or V set? V is clear. We're going to skip negative y EOR. We're going to EOR the value against A. Then we're going to actually skip that, unlike what we were doing before. And then once we do that, we can check. I mean, this is essentially the same kind of logic, right? We're going to say, okay, so if it's positive, oops, I didn't mean to do that. If it's positive, we need to reload the velocity for the y. So reload, what did I call it? Yeah, so we'll call this reload ny velocity, and then reload ny velocity is here. We're going to load A with entities plus entity yvx, right? So that reloads the y velocity. And then what was that somewhat convoluted process we took before? So for that, it just falls through. Otherwise, we just store. Yeah, okay. So otherwise, we load A with the max negative velocity, store it in entities y velocity, jump to, again, I'm just looking to keep this consistent, skip x yn velocity cap. So we're going to skip that, which means we're not going to load it. We're going to just go right here. And hopefully, other than range errors, we should be good to go. So same thing, we're going to do this here. We're going to say branch if equal to L process bullet, jump to process bullet. The joys of assembler. All right. And that is looking a lot better. It's not going crazy. It's doing the motion like I want. It's kind of doing a little bit of a sliding stop. It feels a little bit more fluid. Okay. Of course, now the flybys are broken. The bullets are working, but the flybys are broken. Awesome. Process. L process flyby, jump to skip entity. I think that was probably right. Yes, that was why. That was just because of all the nonsense with the range errors. I messed up the logic there. That should be working now. There they go. Cool. All right. So we've got that working now. The motion is a lot more reasonable. We can play with that as we need to. Maybe we can get to loading the title screen now, and then we'll call it a night. Who knows what fun adventures that will hold for us. So part of the problem with what we're doing right now is we're loading all of these assets for the ship and the background at startup. We don't really need to be doing that because realistically what we want to do is we want to set all of the stuff up that we need for the respective parts, like the title screen, or when you're actually playing the game, in the state machine, well, in the state that we've defined for that purpose, right? So if we go back to what we talked about last time, we said, okay, the first thing we're going to have is we're going to have a state called load title screen, and that's going to just transition once the assets are loaded to the title screen state, and that is going to wait until the start button is pressed to go to load. Oops, we can turn that into a circle. That's going to be load game. right? And if the start button isn't pressed, it's going to just sit in a loop in this state. That's fine. So right now what we want to do is we want to tackle this part. Before we do anything, I want to commit these changes because this is a we made a lot of progress getting this working. So fixed physics for ship so that it properly caps movement in negative and positive direction. Good. See, selected. And of course I could be doing this from the command line. I just think it's visually simpler to be using source tree. Before I do anything, anybody have any questions here that they want me to answer before I go on to loading the assets? Sorry that it took so long to troubleshoot. It was kind of a weird one where, you know, it was just the label being in the wrong place and kind of made it was hard to see. All right, I'm going to move forward. Obviously, if you have any questions, put them in the chat or post them on the video, on the recording on YouTube. All right. So what we're doing initially here, it's fine that we're clearing the entities. We do want to do that. We don't need to be loading the palette anymore here. I mean, we could, but the thing is that the palette is essentially specific to the portion of the game that we're currently in. So the title screen might have a totally different palette than the main game itself. So we can move this code to, let's see, to load title screen. Right. And then we have this code that sets up the background. And realistically, what this is doing is it's doing so it was setting up a couple of things. It was trying to load the background from this BG load low and high, which are just bytes that were getting initialized to some locations in memory. So let's see, so 3C0, let's see, I can't remember where that is. Is that, let's go to the handy dandy NES wiki and take a look at the reference here. So the name tables, yeah. So the name table starts at 2000 in the PPU memory, and you get to that by writing the value of the address that you're trying to reference into the register 2006 here. So you write the low byte and then, you write the high byte and then the low byte, and then you proceed to write the values you want into 2007 here. And every time you do it, it increments the address you're writing to. And there's a mode that will increase either linearly, so that if you are just populating the screen, so there's two ways that it will increase. There's one where it will increase just across the screen so that you're doing essentially line by line. There's another one that every time you write, it will increase by 32 because you're doing an update down the screen. And that is helpful for horizontal scrolling, which we are not doing right now. But I wanted to bring that up. So I don't think this is actually even necessary anymore. The Y was being used in this outer loop that it was doing. Again, this is not necessary because realistically I was just faking the background essentially. Oh, okay. That I remember now why I was doing this. So I was doing this because I was using this as these I was using these variables as counters for populating the background star field, which, you know, it works, but it's not really necessary. It doesn't really do anything for us here. And then this is loading the attributes. So I don't remember if we talked about that too much, but when you have your name tables, you have the screen data, the tiles that you're trying to load, and then you have the attributes for each of those screens. And the attributes are these bytes that you write that control sections, portions of the screen that you're updating. So if you look at the dimensions of the screen on the NES, it's 32 by 30, right? And that's 960 bytes, but the screen is defined as being 1024 bytes. So what are those extra 64 bytes? Those extra 64 bytes are these attribute values that control, what is it? Is it 8 by 8 pixels? Yeah. So there are larger, the screen is subdivided into these larger 8 by 8, or if you want to think about it in terms of tiles, 2 by 2 tiles, and the attribute controls the color. Let's see. Yeah, so it controls the palettes that are in use for the tiles that are here. So it gives you a little bit more options in terms of using different palettes on the screen. But it is, did I say 2 by 2? I said 2 by 2 tiles. I meant 8 by 8 tiles by 8 tiles. Sorry. Right. Let me see. Is that right? If that's 8 tiles. If it's 64 bytes divided by 8 tiles, there are 8 of those. Yeah. I think that's right. Yeah. So each of those controls one of the 8 by 8 chunks of the screen. I think I'm doing that right. Maybe I'm not. Is it 32 by 32 or is it, let's see. Sorry, I just don't want to be giving you the wrong information here. Controls palette of 32 by 32. Oh, so it's 4. Okay. It's 4 tiles by 4 tiles. It's divided into 4 2-bit areas. Each area covers 16 by 16 or 2 by 2 tiles. The size of the block. Okay. Bits 3 through 2. For the okay. So yeah, so it's a little confusing. Sorry about that. It's just a way of controlling which palettes are in use for the different parts of the screen, and I'm sure I will thoroughly confuse that as we go through again, but I just wanted to cover that in some more detail so you could see it. They do a much better job of explaining it on the NESDev wiki. Anyway, all I was getting at is that we don't need that loading here because, again, we were essentially hard coding in that star field, which doesn't make a whole lot of sense to do, given that that is for the game state and not for the title screen, right? So if we now run this, we probably will only see the sprite for the ship and then random stuff, and that's because this name table is now only initialized to 0, and 0 is not a blank tile. 0 is actually now the tile over here. If we go to YYCHR, do I have that open still? It's this tile right here, which is why you have that. So what we can actually do, we can do a couple of things. I think I probably just want to make this, I just want to shift this all over. No, but if I shift it all over, then no, I could shift just this row over. Right. That actually works out perfectly. So shift that all. Yeah. All right, so that's all shifted over now, and then if I rebuild this and rerun it, hopefully we'll get a black background like I was wanting in the first place. Okay. Now we still have the player entity. We can fix that by changing this code here so that we don't initialize the player entity to be separate from the other entities like we currently have. So what we want to do is we want to change this so it doesn't skip the first entry. And then we're going to comment this out because we're probably going to want to come back to this code later at some point. And we just don't want this player entity to show up anymore because we're in the title screen state. Yeah, okay. So now we're in a situation where nothing has been loaded. So let's start with just getting the text for the title screen to appear correctly. Forget about the palette or anything like that right now. This is actually, it's loading the palette. You can see the palette is loaded because we are still seeing things in the right colors, and we have this one palette color that's being rotated. We can probably disable that at some point, but let's leave that alone for now. So let's see. I'm okay with leaving that since we're basically using the same palettes anyway. What we need to do now is essentially work out how we're going to load the text onto the screen. Now, realistically, we'd probably want a tool to do this. And I'll leave that to you guys watching the videos. You can leave a comment or let me know what you think about if we want to show how we would make a tool like that on stream, or if you just want me to build that and we can use it. Let's see. Somebody, Titty-ish, is that right? Asked the question, if I were to get into Python practicing for a few hours a day, how long would it take me to get on your level, and how long have you been coding for? So I've been coding for 20 years professionally, almost 20 years. I've been programming for a little bit longer than that. I started learning how to program on my own by just picking up books from the library because I didn't have the internet at the time. And as far as, you know, how many hours a day, I mean, I wouldn't think about it that way, because I mean, it's kind of a backwards way to think about it. I think what you're better off doing is, and this is what I did, is thinking about what you want to actually build. Right, think about something, and it's got to be within reason, right? You don't want to sit down and say, okay, I'm learning Python and how to program. I'm going to build World of Warcraft, because that's not going to happen. Despite the number of people who have come onto forums and claim that that's what they're going to do. You got to be realistic about it, but if you want to learn and you want to improve your skills, I mean, you write code. You create projects for yourself, even if they're stupid and seem simple. You know, that's. I mean, I think that's where everybody starts. You know, make a Tetris clone. Write an application to do things that you want to automate on your computer. I remember I would write just literally any kind of program to do anything. Just, you know, simple drawing programs. I would figure out ways to incorporate stuff that we had to do for homework, like in our algebra classes where we were doing graphing. I would write code to do the same kind of graphing we were doing on paper in software, and I would imagine that it's a lot easier now with some of the libraries that are out there and some of the programming languages that simplify the graphics stuff. So, you know, hopefully that answered your question. It really is just a matter of just writing as much code as you can. You know, it's the more you write, the more you understand why you're writing the code you're writing, and the more you can then expand upon it. And pretty soon your programs are getting more complex and more complicated. Well, that's a little redundant. They're getting more complex, and you're adding new things to them, and you're thinking about new things you want to do, and you're then kind of going out and researching how to do it. And the key is really to be persistent about, you know, doing that research and understanding what you're doing. Because I mean, for me, when I was learning, I would get impatient, and I'd look at documentation and just be like, I just want to write the code, and not really read or understand what I was doing. You know, and eventually I'd get there, but it's definitely a lot more complicated to do it that way. You know, you got to be patient with yourself, and there are plenty of people around that I'm sure can give you help if you have questions. You know, all over the place. The internet has made that a lot easier. So, again, I hope that helped. If you have any other questions, you can ask them in the chat. You can find me on Twitter, you know, on Nintendo Age. You know, again, there's no shortage of people to answer questions, but I'm certainly more than happy to help. So anyway, we're at this palette load. We're okay with loading the palette this way, but so yeah, let me know what you think about in terms of, like, do we want to write a tool to take our graphics and convert it over? Do we want to do that on stream in a higher level programming language, or do you want me to just focus on just doing streaming in assembler and struggling through that? You know, it's a different kind of challenge than writing a higher level application that's going to do things like turning PNGs into tiles, and then you know, optimizing the tiles and generating the data for displaying the tiles. But anyway, it's a whole different discussion. So we can look into that if you want. Otherwise, I'll do that off stream, and then we'll come back to it with the tool and just make use of it. So let's do this. So title screen here. I know that the first byte of the title screen, of the char-rom, is going to be a blank, right? It's just a blank tile. So we're going to want a bunch of those. And what I'm going to do is I'm going to use a run length encoding for representing the screen, just to keep things straightforward. So basically, the run length encoding will be, I will say, okay, I mean, it's as the name implies. You say the number of tiles that you want, and then the tile number, right? I mean, that's like the simplest way to compress stuff like that, especially if you have a lot of repetitive data in your graphics or tile sets. There are other things we're going to look into that people use. This concept of meta tiles, where they've essentially grouped smaller, grouped the 8x8 tiles into larger representations of sets of tiles, so that they don't have to store as much data to store their levels. But honestly, I haven't worked with that at all yet, so that'll be something new for me as well. Right now, what I want to do is just get this displaying. So what I'm thinking is, what we'll do is we'll do a simple format where we say, what I'd like to do is I'd like to be able to say, okay, we're run length for a certain number of bytes, but if we get something like FF, then that turns the run length encoding off, because we're doing single tiles. And the only reason that you'd want to do something like that is because you want to say, okay, you know, I need a bunch of these, and then I know I have a stream of tiles that I need to put out onto the screen that are single value tiles. I'm not reusing any of these things for the title. So there's really no reason for me to encode that there's a 1 byte length. It's actually more verbose than putting just the tile number, right? So what would be better is to be able to do exactly what I said, say have a whole bunch of these, and then say, okay, FF as like a command to turn off run length encoding, and then the individual bytes that represent the tiles that I want to represent as 1 byte values that are uncompressed, and then switch back by sending an FF again. So the downside to that is you can't do a run of 256, but on the flip side, I don't think that that's such a big deal. So we have FE, right? Let's do this. So we know that the NES screen is 32 by 30 tiles, and so if we're halfway down, it's 15. So let's say when we get to line 14, that's where we want to start drawing the tiles, because they're gonna show up roughly centered. So what we want to do is we want to say 14, well, I didn't really want to zoom, but that's fine. 14 times 32 will get us all the way down the screen. We'll probably have to do a few more over here on the left to kind of push it out. How many tiles are we here? So we've got, is it gonna, what are you doing, YYCHR? Thanks. So how many tiles is that? Is it going to tell me how many I've selected? Is it 8? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 12. How come it doesn't tell you how many you have selected? Or maybe it does, and I'm 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, okay. So that's 12, right? And then for the rest of the word, 1, 2, 3, 4. 1, 2, 3, 4. I gotta change the way it's representing this. I really need it to be a line. I thought okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 12 and 9. That's gonna be 21, and then so half. Of course, it's not an even number. So I'm just trying to calculate how we're going to center this on the screen based on the tiles, the number of tiles. So it's 21 tiles across. So right down the middle, if it's 21 times 8 divided by 2, that's 84. That's 10. So we're going to have 10 tiles to the left. Is that right? Yeah, so 10. So if we're going 30, so it's 20. So all right. So what I was doing is I was trying to figure out, okay, how many tiles do we have in the title here, and then doing the math to figure out, okay, how do I center that, and then how do I offset? So if it's 21 tiles, then we're roughly saying that it's going to be, you know, like 10 tiles here. But more importantly, what I really should be doing is I should be saying, okay, if it's 32 tiles across and it's 21 tiles total, right, then that gives me 11 tiles. So you've got 10 over here and 11 over there. I'm sorry, no, 5 over here and 6 over there, or something like that. It's not going to be centered. We can mess around with that. That's not super critical. So basically we're going to offset by that 5 here, and let's see what that actually gives us, if that's going to be multiple runs or not. So 14 times 32 is 448. It is. So minus 254, that's one run. Okay, so it's one run of 254 for the first tile, right? So for tile 0, we have one run of 254. And then we have 194 left. That's C2 in hex, according to our handy-dandy calculator. And that will give us all the tiles for up to the point where we want the title to appear on the screen, because this is just a linear buffer of memory, right? So we're just going to stream out those 0 byte tiles until we get to this point, and then we want to start with byte tile 1, 2, 3, right? Is that tile 1? Yeah, tile 1, 2, 3. Okay. So at that point, what we're going to do is we're going to turn off the run length encoding, because we don't want to do that anymore, right? We were saying that FF is reserved for turning on and off the run length encoding, and so then I'm going to start outputting these tiles. So let's see, so 1 through, what tile is that? I wish it wouldn't do that. Sometimes it gets into this weird mode where it doesn't select the tiles like in snap mode, like you'd expect it to, and then it's just weird. I don't know why it does that. Okay, so that's tile 12, right? So, right, because, okay, so 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that gives us up to there, and then we want the rest of the word, which is crammed into here, and that is tile 30. 30 through, let's see, what is that tile over here? 30 through 38, 31, 32. And hopefully you can see why I'm saying you probably want a tool to do this, so that I'm not sitting here typing just numbers out and, you know, inevitably making mistakes, where we could probably have something a little bit more efficient, right? Let's just see how this works. But basically, all right. So then what I want to do is, do I want to have the number of bytes that are in this compressed? No, I don't want to do that. I don't want to do that. What I want to do, I'm going to say something like, if you get 2 FFs in a row, then consider that to be the end of the sequence. I think that'll be possible to do. We'll find out. And then obviously, or maybe not obviously, but to my mind, we should be able to make this something we could reuse. But for now, I just want to get a proof of concept here that we can do this for the title screen, or any any background really. So what I want to do is I want to load now. How did I do this with the, so with the palette I loaded let me just confirm. Is that the actual label down here with the palette values, or did I load it into? Yeah, okay, that's all right. Cool. So that's actually that. So so what we want to do is load X with 0, because that's going to be our position in the title screen data, and we're going to say, okay, I want to load A with, I think I called it title screen. Let's I think this is going to be, no, I didn't use that somewhere else. Okay. Hopefully that won't be confusing. So I'm going to load that, and then I'm going to compare it to FF, and then let's see. We're going to say, am I using these anymore? Can I get rid of these? Can get rid of these. So we can get rid of those. Can get rid of those. Right? VG high. Yeah. So what I'm going to just create is just a temporary byte that we can use for a bunch of different things. So now, what I want to do is I want to say, okay, so let's do this also, just to make sure that tile load state. Just want to do this so that I'm referencing it by a string rather than by just a numeric value. As you've probably noticed, it's easy to get lost in what you're doing with so many different short labels and instructions, and it's sometimes it pays to be a little bit more verbose. So no compression equal to 1. So by default, compression will be on. Load A. Tile load state. Just to make sure. Right, so when we go into it, it'll be run length encoding. And then branch if not equal to, we'll say run length decode. So if we hit this, then what I want to do is I want to increment X, and then I want to just check to see if it's FF again. Branch if equal to done loading. Right, so this is done loading. If it's not equal, then what we want to do is we want to go back to the beginning of the loop, where it will well, actually, it shouldn't be, well, I'm getting ahead of myself. We should go back to the beginning of the loop where it is going to load background. Right? So load background. All right, so do that comparison, and then based on let's see. So what I want to do is I want to say based on the type of compression that's set. So let's do this. Compare. I gotta store this into temp, right? So compare. Hold on. So I just want to make sure I'm doing this in a logical way. So if I'm coming into here, what's the first thing I need to check? I guess it depends on the compression that I'm running. Well, it doesn't really matter. I'm going to look at the byte no matter what. And then I'm just going to flip the compression mode if it's not the one. Yeah. So I'm going to compare it to that, and then I'm going to branch if it's not equal to something like handle data or process data. Otherwise, okay, so right, so process data. Otherwise, I want to go to the next byte and I want to see, okay, is the byte FF again? If it is, then go to done loading. Otherwise, yeah, so then I want to do this. I want to load temp. I want to EOR with 1 because I want to switch the encoding method, right? So single FF implies switch encoding, which we can do with the exclusive OR because we're just switching between 0 and 1. So I don't even care what the previous state was. I'm just switching it to the opposite state by using the exclusive OR. And then it goes back to load background, which now looks at the byte that we're currently that we incremented to, which is fine. If it's not FF, then it's going to go to process data. Now process data has to process the data differently depending on if we are loading through run length or if we're loading single byte at a time. So we want to load A with temp, and then we want to compare it to tile load state, run length encoding. If it's equal, go to load run length. Otherwise, it'll be single byte, and then jump to load background. This should increment X. That's fine, and then we need load run length. So if we get to load run length, that means the first byte we have is our counter, right? So we want to effectively load Y, because we're going to use Y as our counter. Load Y with, well, yeah, we need to load Y with title screen X. The reason we need to do that, I was thinking we could use the value that's already in A, but we clobbered that when we were looking at what the compression method was, or the compression state, I should say, was. So we're going to load Y with the counter, and then we're going to increment X, and then we're going to load A with the actual tile, right? That's the tile. And then we're going to create a load run length loop here. And we're going to store A into, now I know that we haven't set that up yet. That's going to store it into the background. That's fine. I want to finish this thought, and then we'll go back to how we have to set this up properly. So I'm going to store into 2007, which is the register for writing to the PPU. And then we're going to decrement Y. What is it? Is it DEY? Seems like it should be, but yep, it's DEY. Okay, and we're going to decrement that because we're counting down from the number of bytes, right? And then let's see. So, and then if it's equal, right, which means that it becomes 0, then we are going to, so okay, so if it's not equal, then we do we loop back to the top, right? So for each time through, so if Y is 1, we're going to store the byte 1 time and decrement, and then we're going to say that it's equal, right? Because A will, oh no, actually it won't be. We need to, won't be. We need to compare Y to 0, and that'll be fine. That's. I was thinking we were doing it in A, and if A becomes 0, then it considers it to be equal, but because it's 0, and so, but that's not the case here because it's in Y. So we're going to have to compare Y to 0, and then if it's equal, we will fall through. Otherwise, we're going to loop back to the top. For the single byte case, well, again, let's not get ahead of ourselves. So then once we're done, we're going to increment X and jump to load background. That's fine. Okay. Now before we do anything with the single byte case, what I was saying before is we're storing to 2007 to load the name table, right, with the values, the tile values, but the problem is that we never actually set that up anywhere. So what we need to do is we need to actually make that happen. So we need to clear the register to let the PPU know that we're going to give it an address that we're going to write to, and then we're going to write to 2000 because the name table starts at 2000. Is that right? Yes, that starts at 2000, and then except I'm not going to do that. I'm going to do this. I'm going to load it as 2 bytes. So the more significant byte that is 20 because it's 2000, and then load A with, or most significant bit, I should say, because it's, or byte, and then the least significant byte, the lower byte, is going to go into there. And so now we've told the PPU that we're going to be writing bytes to it. So now when we write to 2007, we're writing to the address 2000 onward. So now this is okay because we're storing the tile into the name table accordingly. So that's all good. We increment the X value because we want to get to the next byte for this. So now for single byte, where we're not doing any sort of compression, we're just literally loading the value in, right? So we want to increment the X to get to the, no, we're already at the byte that we want. So we want to branch with not equal process data. Yeah, so we want to load title screen. We're going to load X, and then we're going to store A into 2007, and then we're going to increment X, and that's that. So that's probably broken, but that's roughly the right way to do it. Now what? Of course. Man, this is such a pain. Well, let's take advantage of the fact that there's a fall through here, and that, okay. So let's create local, which is the one that's at load new game state. That's just going to jump to load new game state. So this becomes that, much nicer, shorter jump. And then this is local. Well, let's make sure that I didn't. What did I mess up? Oh, I have an extra G. Error. Load new game state. Undefined. 253. Load. Oh. Underscore. Yes. Local load new game state. Come on. Be consistent. You can do it. 242. Okay. Same thing with this guy. So all of these are probably going to have this problem. Local title screen state jump title screen state, and then local gameplay state jump local gameplay. No, I don't want to do an infinite loop. 248 pause state. Okay. Okay. So we've thoroughly kludged that. See if anything actually loads on the screen. Okay, well, something loaded. I'm moderately pleased about that. Let's see. Let's step through the code here to see what actually got broken about the way that it's doing it. So load A with 0 and then store A into address 7FE. We'll use that trick again and go to the hex editor. Let's find that address. I may already have that. Let me just clear those now. Execute and write. And let's reset, or not reset, reload. Okay, so we're at the point now. Oh, that's just initialization. Okay, so we're loading X, we're loading A, we're storing A. 0. Okay, that's temp, saying we're using run length encoding. So now we're going to load A with the value FE. Okay. We're going to compare it to FF. If it's not equal, we're going to go to where we process it. So now we're going to check the compression type. If it's 0, then we're going to run length encoding. So now we want to load Y with FE. Yep. And then we're going to increment X. And now we're going to load the tile that we want to load. And now we're going to store it in memory. Let's take a look at the name table. And we're going to just keep stepping over that. And we're just, yeah, I mean, we're just going to keep going until we get to this point. So let's put a breakpoint here. Okay, so it's 0. We've incremented x. We'll step over, jump there. We're going to get the C2. Same thing. Step over, jump. So we're loading the value into A. It's FF. All right, so now we're going to look at the next byte and see if it's also FF again. Which it is not, which is good. That means we're still looking at the data the right way, because we're at the point where we're now using the single byte writes, right? So okay, so we're saying, okay, branch if not branch if equal to the place where we're done. Otherwise, we're going to load we're going to load temp up into memory. We're going to do the exclusive OR. We're going to store it. So now we're saying we're doing single byte encoding. I'm going to load A with the value of the tile, which is 1. We compare it to FF. It's not that tile, or not that value, so it's not equal. So now we're going to check the compression method. If it's 0, we're going to do something else. We're going to do the run length encoding, but it's not. It's 1. So now we're going to load A with the value that we want to store, and we're going to store it in the name table. We're going to increment x, and I don't see that that actually changed the name table the way that I expected it to. So let's take a look at so that's tile 0, and that's tile 1 here. And the name table didn't get altered, right? I don't see, or did it? That's the x value, that's the y value. The tile value that you can see is here is not, it has not changed. So, oh, wait a minute. Yeah, of course it hasn't changed because I'm in the wrong place. So, let's see. So where would it be roughly? That's actually part of, that's a problem with the fact that the I think what I'm going to do is, instead of making the tile black, I'm going to change the color just so we can see what updates we've done so far. Obviously, we'll change it back, but like we need to have it have some sort of non-default value just so we can see that we've actually updated it appropriately. So I'm just going to literally just kind of make it some garbage that we can recognize. All right, and then if we go back, okay, so that's better, because that means that we're at least doing something along the lines of what we expected, right? So we're actually potentially drawing some of the, well, I can't even say that necessarily, because the default value is going to be 0. Let's do this. Let's just for kicks here, let's change the default, the first thing that it writes is to a bunch of 1s, just so we can see where it updates it to, and then let's just end the sequence here. I just want to see if it writes to where I expect it to write. So if we reload this, so it doesn't. It does not. All right, so I've obviously miscalculated something. What did I do? If it's 32 tiles across, and I want to go down the screen 14, 32 times 14, it's 448 tiles minus 254. That's 254 and 194. 194 is C2. 32, 64, 96. So it's not even getting. It's not even getting all the way down. George Max 99. I'm making a old school NES shoot 'em up. This is more of like a test program I'm building with this. The idea is that hopefully I'll build something a little more challenging once I've kind of gotten a hold of how to use the NES properly, since I'm not super familiar with it right now. I think I know what the problem is. I think it may be that the mirroring is set up wrong based on what I'm looking at in the name table viewer. No, that looks okay. I'm just not drawing enough tiles. Why am I not drawing enough tiles? I mean, that's 254, and if that's 32. Let me just make sure that I'm not doing something ridiculous here. So that's 32. Yeah, that's 32 tiles times 14. That should be like right here, right? Yeah, that's about midway down the screen. All right. What's going on? So wonder if this is happening because it's in the game loop and we're getting an NMI. We should probably turn that off, right? Like, we don't want to have the screen updating while we're updating it. Or let me rephrase that. We don't want to be processing drawing code at the same time as the screen is actually trying to draw our other code in the NMI to handle things like sprites and stuff, right? Because we're loading the background at this point. We don't even necessarily want the screen to be drawing anything at this point until we're done. I'm wondering if that's what's causing the problem. So let's go here. So 2000 and 2001 are the control and mask registers, and we can use them to turn on and off NMI and backgrounds and sprites and stuff. So let's do that. In fact, what we can do is we can move this code, and I think that's what I'm going to do. I'm going to move this code out of here and into the load of the title screen, because we know this is the first thing we're doing. There's really no point in turning anything on until we're done loading the title screen. So let's see if that unbreaks some things. Yes, all right, cool. So that is awesome because it drew the number of lines that I expected it to. That is much better. Okay, cool. And then that also means that our run length encoding is encoding it correctly. All right, so now the next thing we need to do is we need to add 5 to this, because we don't want it to just go down the 14 lines. What we want it to do is we want it to go down the 14 lines plus some characters for our to space our text over to the left here. And then what I can do is I can say, let's make these 0, because let's leave it at 1 for now, just because I'm pretty confident that that's working now. Oops. But it's probably better to just double check that. Yes. Okay. That's much better. All right. So we can turn that off. And then what we can do is we can I'm going to leave the garbage characters, the null characters, just for the sake of completeness here. Just to double check as we go through that things are looking the way we want. Okay, cool. So I think what I want to do, though, is I think I want to move this up 1 or 2 rows, because I think that looks a little bit too far down. In fact, it would be too far down, because let's see, the title is 3 rows high, so it should be at least 1 row of 32 lower. So let's see, so C7 minus 32, let's say A7. So let's make this A7, rebuild. And again, it's like, this is why you want a tool, so that you can just draw it the way you want, and the tool turns it into the representation on the screen that you're looking for. So, all right. Cool. This is good. I'm just curious. Is that gonna? Yeah. All right. Sorry, I'm just messing around with stuff that I should be leaving alone. All right. So we've got the streamer text here, and then we want. Let's see, 1, 2, 3, 4, 5, 6, 11. Then 11 more blanks, right? So we're going to turn run length encoding back on. We're going to say 11 blanks, encoding back off, and then it's tiles. Hello, what tile are you? I wish this wouldn't do that. Why does it do that? Why does it go into single? Select a tile, not just a pixel. I'm not sure why it does that. That's so bizarre. But anyway. And then now it's not. Okay, there we go. Let's see, that's 10, 11, 12, 13. Okay, so 10 through 1C. So I'm gonna break this up into another line. 10. So tedious. What I'm going to do is I'm going to put the terminating sequence here just on its own line, so that I don't have to keep moving it around. Nice. Okay. So the next set of tiles we want are, what is this, 40? Ah, it's doing it again. 40 through 48. Right. Let's see. Oh, what's up with that? Did I take one too many? Should this be 3F? It's weird. Why is it? is not aligning right. It's off by 1 tile, but is it this one? I mean, technically yes, but should I? Oh, I see. It's because... Okay, so let's see. What we really want to do here is add another empty tile to offset the fact that I kind of jammed some stuff together. All right, so let's reset this or reload this. Oops, right. Because now the encoding is off by 1. It should be A. I might just be getting slap happy here. Okay. Wait. I offset it by 1 in the wrong place. So the A ends here at tile OC, and then this should be 0, 0. And then reset. Yeah, okay, cool. That aligned it properly. So I'm going to stop here because it's been 2 hours, and I mean, you get the point. So if we go back to YYCHR, we can get rid of the junk in this, and then it will actually have my rather creative name that I've come up with for our game that we're doing live on stream, which is Streamer. So, you know, obviously there are a few things. The text is not in the color that I want. I don't want blue. It's not fully rendered out. But that's not such a big deal. The fact that it's drawing at all is cool. And then basically where we're at is, now that we have that routine written to decompress the tile data into the screen, into the name table, we can load pretty much whatever we want, switching back and forth between run length and non-run length encoded data. And when you hit the start button to switch between the switch from the title screen to the actual game, we're going to have to go back to adding the entity like we had before, right? Because we didn't initialize the first entry for the entity. Now the entity is actually the entity is cleared out, and we need to create that when we go to the code for starting the game. Like so, right, if we go to load new game, you can even do that. That should be relatively quick to make work. We uncomment that out. The other thing we probably want to do is we probably want to turn off this first by zeroing everything out. Stop it. Wait for a VBlank, and then once that's done, we initialize the entity, and then we turn everything back on again. Oops. I want to do that in the actual game loop, or go to the game loop. Okay. So that, yes, that looks right. I mean, I don't know if that's going to work or not in any capacity. It's certainly not going to be exactly right, but let's see what happens. Okay, so the player ship comes in, and the flickering is occurring. You can't control the player. My guess is that something is... The game state is 4, which I thought was pause. So the controls are not being registered. So, I mean, look, there are problems, and it's because we're completely revamping how all of this stuff works, right? We're loading the screens, and we're switching between states and creating things a little more dynamically. So I didn't expect it to work exactly right, but this is a decent place to stop for now, because... like I said, you know, we can come back to this and fix it up, but we need to kind of figure out, should I be trying to code tools on stream, or should I just be doing that separately? You know, you tell me what you're interested in seeing. I'm happy to do it on stream if you want. It might take a little longer that way because I can't work on it on just my free time because I'm only streaming 2 times a week. But, you know, up to you. You let me know. Let me just go up to the Twitch page on my other monitor here because my laptop's battery died. So I don't know if there are any other questions. Let me just mute my audio here. So if you asked the question before, just now, I probably missed it because the chat room doesn't seem to persist the questions. So if you want to ask one more time, I'm in the chat room now. Hopefully you are not hearing anything from Twitch playing through to the recording or the stream in a crazy loop. So 13 lakh for 3. Okay, so you're saying go ahead and build it on the stream or do whatever I want. That's fine. I mean, like I said, I'm happy to do either one. So, you know, I just wasn't sure if people were more interested in seeing me struggle through assembly language or not, versus you know, doing that separately in something else. Please do build on. Okay. I mean, so far it looks like people are interested in seeing it being built on stream, so I can do that. And then, you know, then the next question, of course, is, you know, what am I going to build it in C#, C++? I don't know, probably C++, just because I don't know. That's like the game thing to do, right? C# has some nice convenience things in it, but C++ is like, you know, what people use for games. I don't know. That's like the worst justification ever. You've got a knack for this. I could definitely not talk about join glimpse and get your thought. Well, thanks. I appreciate the feedback on the stream here. It's yeah, it is. It's tough. It's tough doing the streaming and the coding, especially with stuff like assembly, where you're like literally kind of going through the most basic steps. It's not like where you're doing it in higher level programming languages where you have a little bit more leeway to kind of get thoughts down more quickly. So I'm glad that this is useful and interesting, because it I know there are times where we're, you know, like at the beginning of this stream where I was struggling to figure out the problem that we were having with it not detecting the movement properly, and it turned out to just be something stupid like a label being in the wrong place. But you know, that actually happens, right? Like when you're coding, I mean, not that people use labels, but you know, those kinds of problems will happen, and you know, it can take you the better part of an hour to figure out exactly something like that, where you're just like, oh, that was dumb, you know, a misplaced semicolon or something like that. So how many lines deep am I? Good question. I really don't know. We're just at about 1,000 lines, and you know, just really scratching the surface of what we're doing here. There are a lot of things that we could refactor to be more data driven. I've talked about, you know, like the bounding boxes and the collision. We've done that a little bit, but it would be ideal, I think, to make that more data driven based on output from tools, so that, you know, we're not writing a lot of code that's specific to the entity types other than the logic for, you know, the AI type stuff for the enemies. And again, AI is very loosely used here. Just, you know, there's going to be some basic patterns that the enemies will go through, like in most shooters, you know. So anything else? All right. Well, thanks for watching, and you know, next time we'll continue with this and get the title screen fully drawing, and get it back to the point where we're able to play, and then we'll start on the tools for the tiles and compressing the tiles down into what we were typing out by hand, essentially, and start talking about how we're going to load the level, because I'd like to be able to make it so that as you're flying through the game and shooting enemies, that there is some sort of background that's scrolling, at least behind you, or as a background, if not something that's going to actually interact with you, like that you can crash into. Yeah. Yeah, take care, and see you guys Monday, and thanks again for watching, and have a good night.